Our wooden coaster story begins at Hersheypark, nestled in America's heartland of Hershey, Pennsylvania.
In this country, there is no wooden coaster that both duels and races. And so we said to Great Coasters, you've done a dueling coaster elsewhere. You've done a racing coaster elsewhere. How about combining the two elements into one coaster? And that's exactly what they did.
So the way the ride works is you start in the station, you leave, both trains head out in opposite directions and engage with their lift. They both go up. The first series of drops are sort of a symmetrical shape, and then they split and we jump into what we call the siphon turn. This is where both trains drop about 72 feet and come out of the pull-out 6 feet apart. This is the high-speed racing section. We call it Side Swipe Alley. Both trains are careening through here. The inside train takes the lead. Then our first flyby element occurs where the trains split and we go across one another in opposite directions. We have about a 60-mile-an-hour flyby. Then we go to what we call the zigzag section of the ride where the trains pass under and over one another. They keep changing positions from left to right, and they crisscross one another twice. Then we split and we do our last flyby, and then we bring them back together for the finale and race home. The finish line is right here.
Mike Boodley uses his own customized spreadsheet program to design his center line.
Steve, I know Steve actually has very pretty images on his screen when he designs a coaster, but he's designing a ride graphically, and we're designing a ride purely by equations for curves. And it's quite a few numbers.
Just how many numbers? Over 85,000. Just like Steve's centerline program, Mike's numbers specify all of the ride's information: the track's height, angle and banking, the spacing of the supports, as well as the structural and rider dynamics and forces. Great Coasters then makes a graphical representation of Mike's numbers to create a profile or side view of the coaster.
It shows you all the different elevations of the track at any given point. It's just a real good reference for us when we need to go back and see, well, how high's the track right there? Can we clear under that bridge? That kind of thing.
Coaster makers then send their profile and spreadsheet information on to structural engineers.
We receive from Great Coasters International CAD drawings of the ride plan and profile, along with a ton of numbers, which we, as structural engineers, develop wind forces and analyze individual bent structures. We then develop CAD drawings of the foundation details and plans, which they can build the coaster from.
To ensure safety, all of the ride specifications meet or exceed federal building and safety standards. In the event of a severe storm, the team has designed Lightning Racer to withstand wind loads of up to 100 miles per hour. The making of a wooden and steel coaster can be similar. Both require detailed field preparations. Plotted land must be surveyed for elevations. Information is reported back to the design office to make adjustments in engineering. The designer and engineers then send updated building information back out to the field. Workers can then begin creating the foundation. At Hersheypark, workers dig 4-foot deep trenches. Steel rods or rebar measuring 5/8 to 1 inch in diameter are tied together to provide reinforcement. Cement is then added. The finished product is called the strip footing or strip foundation. It will provide one continuous form of support for the wooden framework of the coaster.
After we pour the concrete, we place our pedestal, we backfill everything, so basically just all we have is a little pedestal sticking out of the ground.
As many as 90 workers, 2/3 of them local, and 4 million pounds of lumber will be required to meet the 9-month construction schedule.
There's over 1 million bolts and over 1 million nuts, not including the krill.
Mike Boodley comes to the site to check on his design.
But when I got to the site, I was very excited to see all the piers in the ground. You know, this ride has over 1,000 vents in it. There's probably about 4,000 pedestals. We're probably about 75% of the way there on foundation. And like all construction sites, we had a little glitch last night. We had a torrential rain of about almost 2 inches in a very short amount of time. And so we're working on rerouting that. And
Luckily, that's Claire's problem. Because of the rain, we had to pull the rebar back out of this ditch again, re-dredge it, and take 6 to 12 inches, probably out of the bottom, to find a good hard surface again. And then we'll have to relocate the rebar back in there and then to pour it. So we've lost a few days because of this.
Behind closed doors, Hersheypark management brainstorms a winning name for its new attraction.
Fast track.
Fast track. That's good. Dual racer, double dare.
Racer.
Oh,
Speed racer, dual racer. Like, we could come up with any name to go in front of racer.
The team produces a list that it will pass on to the park's top brass.
Hey, thanks everybody. Really appreciate it. Thank you. You're awesome.
Hersheypark organizes a press conference to announce its new attraction.
For the year 2000, we're going to unveil this morning, and it gives me a great deal of pleasure to do so, our brand new wooden racing dueling coaster called Lightning Racer.
We actually can start any old place in this ride. Like you can see here, we started here, in this area, we stopped, and we started down in here. Eventually, once we get done with the structure they're building now, we'll just meet them right here in the middle.
Engineering feats like this are accomplished thanks to specialized surveying equipment, like the transit device used by field engineers. Site survey and coaster drawing data have been downloaded into the transit device, so when any 2 known points in the field are located and input, the transit can verify if any part of the structure is perfectly vertical or off base and needs correcting.
I can do anything. I shoot elevations, I program in the height of this pier, the height of the instrument from the pier, and it'll do all the math for you and tell you how high that pier or anything else is on the ride.
Great Coasters also designs and fabricates its own trains. It takes 7 months to make all the parts. Then for another month, the Great Coasters crew spends 12 to 13 hours each day assembling the 4 trains. Each train has 12 cars and 54 wheels. The unique design of the cars may look old-fashioned, but unlike the coaster trains of the 20s, Mike Boodley's cars have been engineered to handle the extremely tight curves of his track design. They also require parts created from modern fabrication methods. At Bob Patton's Doo-Wah facility, a variety of equipment creates parts for the Lightning Racer trains.
You can program something in AutoCAD, which is a software package for drafting purposes, put it in the laser, and the laser will make it. This finish is very nice and smooth. This is an untouched finish. That's exactly the way it comes off the laser.
The crew takes particular pride in the craftsmanship and quality of their parts. The car bodies are made of steel and aluminum, and the running boards are made of oiled teak wood.
A lot of people are doing fiberglass now. It's a lot cheaper, maybe a little bit easier, but we like the classic look and the classic style.
Great Coasters also uses rolled or hand-stretched vinyl upholstery with foam padding.
It's a lot different from most of the other things that are out there right now. We kind of wanted to go with the comfort a little bit. Makes a wooden coaster fun.
While a great coaster has to be fun, it also must be safe. Each of the 12,500-pound trains features built-in and redundant safety mechanisms.
Well, we have an individually positioned lap bar system. This is one side of it, and there's going to be another side for this other seat when we install it. And this adjusts to several different heights for different sized people. Like a person that's pretty big like me, felt that I'm down just a few clicks, but if I was riding next to somebody who's very small, they'd be able to push the lap bar down much farther so they can be a little bit more secure in the seat. So if I could just get somebody to let me out of here, I could show you some other interesting parts of the cars. Somebody can just let me out of here. Anybody?
At Hersheypark, construction of the Lightning Racer is complete. The 90-foot lift hills are ready to race, and the 68-foot turnarounds are ready to duel.
And this is the finish line.
The finish line is the moment of truth, when riders find out which train won the race.
All right, this is the end of the ride. Both trains have just done their final flyby. They come barreling up. They get right next to one another on this double drop up. They come up the double drop, and they come racing for the first set of brakes. These bluish-green sensors that you see are what determines who wins. Whoever gets to it first is the winner of the race. Then the brakes start. They're the first brakes on this entire ride from lift top to this point.
While Lightning Racer is a wooden coaster, it also uses steel.
With the top steel and the side steel on both rides, we basically have around 27,000 feet of steel.
Hopefully Claire and I won't be crying because it could get stuck. Good luck, Claire.
From the second the trains are dispatched, computers underneath the station receive vital information from sensors in the station and on the lift hill.
Okay, what you have here is inputs that is out on the actual track. It lets us know, or the ride know, where the train is at all times. At the same time, it also operates brakes out on the ride, and it will also let you, or it won't let you, dispatch a train, depending on where the other train is at. It is ensuring your safety at all times.
Up on the loading platform, another set of controls governs the safety and smooth operation of the ride.
Oh yes, it's slow. We're okay. That was plenty of speed. Congratulations!
Meanwhile, Great Coasters contracts GMH Engineering to conduct dynamic testing aboard Lightning Racer, which requires an accelerometer and a dummy named Fred. But Fred is no ordinary dummy.
We have a neck sensor in Fred, and we can measure the forces that a passenger would experience from the dynamics of the ride.
The collected data verifies Mike's projected speed and G-force calculations, and that Lightning Racer falls within average safety limits. While Fred confirms the math and science of the design were correct, the dummy fails to tell the coaster makers if Lightning Racer has passed the fun test. That will have to wait for opening day.
Well, now that the job's over, it's a great feeling to have completed it, but it's kind of sad to leave the site and kind of turn it over. I guess it'd be like having your kid go off to college or something. We're leaving it in the hands of Hersheypark, and we know that they'll do a great job taking care of this ride.
Good job.
Yeah, congratulations, buddy.
That is done.
Me too.
On May 13th, 2000, the grand opening of Lightning Racer finally arrives. A long line of people stretches outside Hersheypark's front gates, awaiting their first chance to ride the world's first dueling racing coaster.
Well, this is a fantastic season coming up at Hersheypark. First and foremost is Lightning Racer.
The first riders hop aboard the two trains of Lightning Racer. Their screams and smiles say it all.
The wood factor on this roller coaster makes it really great. That's neat where you normally see metal. Well, the top things are probably speed. A lot of changes in direction. And dips and turns.
Yeah, today it's a feeling that any coaster designer and builder like to feel and see the excitement of the people as they get off the ride. I mean, how can you not get no enjoyment out of that?
Lightning Racer, where the heaviest train wins.
Well, this is it. 9 months of building, and we finally get to enjoy the fruits of our labor. Lightning Racer's up and running.
Mike and I are here today. We're racing each other.
I'm on the Thunder side. My buddy and friend players over there on Lightning.
They say it's a builder against a designer.
And we knew this race was coming up, so we've both been putting down a lot of food, trying to increase the old weight factor, you know? But I think I still got Claire beat.
I came home last night from McDonald's with a cheeseburger and french fries. Mike came home last night with 10 Big Macs, a couple large fries and a large shake and a large drink.
And we're rounding the top.
So here we go. We're going down the drop hill.
Yeah! Woo!
Hey, buddy!
Hey, we're neck and neck. Yeah!
We're side by side. We're at the cycle turns now.
These two turns bring both coasters directly in line with each other and into the tunnel. I got ya!
We're in the racing section now.
I got the advantage now. Woo-hoo! Oh, it's catching up.
If I wait a lot more, I'd probably be able to catch him. But he has a big advantage on me here.
Then we go through the zigzags. Thunder goes over lightning, and lightning goes over thunder.
Oh, he's not that far ahead. Come on, boys. Let's go. Hubba, hubba.
And on to the last flyby of the ride. Woo!
Oh, I don't know.
Oh, I got him.
Yeah, he beat me by 2 train lengths.
I got him. I beat you. You need a desk job so you can put on some weight, my friend. And foremost, we have to give a park a spectacular ride that people are going to want to ride. They're going to want to run around and get in line again. And we have to give them a very safe ride because millions of people will ride this ride from this day forward.